Good morning. Today we're going to go over our week 4 assignment. So that's assignment number 4. We're going to practice our creating universal plotting sheets and then plotting the LOPs. Then we're going to practice creating assumed positions. And then we're going to practice our pub 229s and how we get what we need to plot. And then we're going to do a full site reduction. So we're going to start with creating plotting sheets, and let's get started. Okay, so this is our basic plotting sheet. We have the longitude scale down at the bottom. Our latitudes are already on here, and you can see the 60 minutes are already there for us for each latitude. So you have 4 latitudes, this 1, 2, 3, 4, 5, actually 5 latitudes. Our mid-latitude goes through the middle, and our mid-longitude goes through the middle here. So we have to put in our longitude lines. They are not there for us because they change with latitude, where our latitude always stays the same. So we need to create our longitude lines. So what we start with is our latitude. In this case, for number 1. For number 1, we have a mid-latitude of 30 degrees north. So that makes this 29 degrees north, 31 degrees north. Now we need to put in our longitude lines. So I'm going to use, on our scale down here, we have mid-latitude and then our longitude scale. So this is longitude 50 minutes, 40, 30, etc. to 0 and then 10. So if we go all the way across, so here's the 30 degree line. So I'm just going to make a line so I know where I'm at. And if I go all the way from one end that would be 60 minutes of longitude at a mid-lat of 30 degrees. So then I can mark this on our plotting sheet. And now I can draw in my longitude lines. Okay, so now I have my longitude lines for 30 degrees north. Now I'm going to start labeling. My mid-longitude was 130 degrees west. So I have, this would be 129, 128, 131, 132. So now I have a good scale of my latitude and my longitude lines. So our first step now is, or next step, is to plot in our DR. So they told us at 0800, I have a DR position of 30 degrees, 20 minutes north, 130 degrees, 40 minutes west. I'm on a course of 060 degrees true at a speed of 12 knots. So in order to plot this, we have our latitude scale is right on the middle of the thing, so we don't need to use anything different. So we were at 30 degrees, 20 minutes north. So here's 30 degrees, 20 minutes. So I'm going to draw in a latitude line. I'm somewhere along that line. Now I'm at 30 degrees, 40 minutes west. So I go back down to our longitude scale and find 40 degrees. So here is 50, here's 40, and then this is 0. So I'm going to put my point at 40 degrees and then get it to the 0 mark, which is right about here. And this goes by 2. So this would be 42, 44, 46, 48, 50. So here's our 40 degrees. So we were at 130, 40 degrees west. So I'm going to put my mark here. And this is going to be my DR position. So next, so I could draw in my point, I'm going to draw in our course. Our course was 060 at 12 knots. So I'm going to find 060. So this is a course of 060 at a speed of 12 knots, and this is my 0800 DR position. So now that I have my DR position and my track line, this is how we set up our universal plotting sheet. Now I'm going to move to number 4, where we plot our LOP. So for number 4, they tell us we have an assumed latitude of 31 degrees north, assumed longitude of 129, So our first step in plotting the LOP is plotting the assumed position. So this is our assumed position. We are on 31 degrees north, and my longitude is 23.3 west. So I'm going to find 20. There we go. I'm going to find the 20. And then I'm going to find the 3.3. So if this is 2, this is 4, 3.3 is going to be in the middle there. So do as best you can to find 23.3. And our longitude was 29. So we're going to start at 29. So very close to our track line, but that doesn't mean anything. This is our assumed position. So now we have an assumed position. Now we're going to get our bearings to our body, whatever our celestial body, whatever we found. Okay, so our bearing is 221. So I'm going to find 221. I'll do it a different way so we can see using a roll plotter. Here is 221. So now I'm going to parallel it up. In this case, I'm going towards 221, not away from it. So from my assumed position, I'm going to go towards 221. So this is my bearing line. Now, in order to draw my LOP, it's going to be perpendicular to this azimuth or bearing line. So I need to find how far on this line I'm moving, and that's what our intercept is. So our intercept is 7.0 nautical miles or minutes. So I'm going to find 7 right here. So I have 7 nautical miles. I start at my assumed position and put a little mark at 7. And then I'm going to draw in my perpendicular line. So I use the triangle. So this is my LOP. It is perpendicular to my bearing line. So if I wanted to, I can erase the extra lines that I have on here just to clean it up a bit. Erase this in position if you want. But that is our LOP. Let's do the next practice one. Okay, now we're on number 2, and we have a DR position of 15 degrees south and 80 degrees west. So we're going to set up our universal plotting sheet with our mid-latitude of 15 degrees south. So that would make this 16 degrees south and this one 14 degrees south. My mid-longitude is going to be here, 082 degrees west. So now I need to write in my longitude lines. So I have my mid-latitude at 15. So I'm going to find 15 on my longitude scale. So here's 15. I'm going to draw in that line. So this is my 15 degrees south. So if I get the whole 60 minutes of longitude, I can draw in my longitude lines. So let's find that. Okay, so now I'll draw in and we always want to label our lines. So if this is 82 west, this would be 081, 080, 083, and 084 degrees west. So now we have our latitude line labeled and our longitude lines labeled. And now we can plot our DR position, our course and speed, and then we can plot our LOP. So our DR position is 15 degrees, 15 minutes south. So if this is 15 degrees, 15 minutes south is going to be in this direction. So these minutes of the latitude are based in the northern hemisphere. So we have to work our way a little bit backwards. So if we're going 15, here's 10 and 5. And we are working from 80 degrees as our DR. I'm actually going to put this here and draw in my latitude line at the 15 degrees south, 15 minutes. So that's my latitude line. Now my longitude is 08045 west. So I'm going to find 45 west. On my longitude scale, I start at the 40 and find 5. So that's going to be in between the 4 and the 6. So right about there. And I'm at 80 degrees west, going west to 08045 minutes. So this is my DR. So that's my DR, and now I need to plot my course. My course is 240. So this is my DR at 800. I have a course of 240 degrees at a speed of 5 knots. So now I'm going to plot my LOP. So I need my student position, my intercept, and my azimuth. So I have my assumed position here. I need to plot that. I'm going to be on the 16 degrees south line, and then my assumed position is 08325.9. So I need to find my 25.9. So almost 26. Right about there. So I'm on my 16 degrees south, 08325.9. So this is my assumed position. Now I need to plot my azimuth and my intercept. So my azimuth was 341, and it was away. So I'm going to find $341. Bring that down to my assumed position. So 341 is in this direction, but I'm going to be going away from 341. So from my assumed position, I'm going away from 341. So that will be my azimuth line, going away from 341 in that direction. My intercept is 29.7. So I need to find 29, almost 30. Get as close as you can. From my assumed position, away from 249, right here is going to be that intercept. So now I draw a line perpendicular and that line is my LOP. So I don't know, I don't have a time for my LOP. I could be anywhere along this LOP line. It has nothing to do with my track line. So hopefully another one is more on the, has a different bearing. But that is our LOP line for number 5. You can erase all the other stuff if you want. All right, let's do one more. Okay, so number 3, we have a DR of 35 degrees 55 north and 025 36 east. So we're going to put in our mid latitude at 36 degrees north. So that makes this 35 degrees and this 37. My mid longitude is going to be 0 to 5 degrees east. I need to put in my new longitude lines. So down on our longitude scale, I'm going to find 36, so just above our 35 line. We'll call that our 36 degrees north, mid-lat. And now I will measure the 60 minutes of longitude. So right about there, 60 minutes. I'll put in my marks so I can draw in my longitude. Now I have my longitude lines, I need to label them. So we have 25 east, so that makes this we have our longitude lines and our latitude lines set. Now we can plot our position. Here's our DR. We are at 35, 55 degrees north. So I'm somewhere along that latitude line. My longitude was 36 east, or 25, 36 minutes east. So I'm going to start on the 30 and find the 6. So it goes in 2s. So right here would be my 36. And now that 25, 36. So here's 25 going 36 to the east. This is my DR position. So I can erase my course was 350. Let me get my course. So here's my 0800 DR, a course of 350, and a speed of 18. Now I have my DR and my course and speed. Now I can plot my LOP. So that is number 6. Okay, our first step in plotting the LOP is plotting the assumed position. So we have 35 degrees north. We're going to be somewhere along this line. And then we have 25 degrees, 30 minutes east. So I need to find 30 minutes. So on the 35 line, 25 degrees, 30 minutes is right there. So this is our assumed position. Now I have a bearing of 089.8, so about 90 degrees, and 12 to that direction. So I'm going to find my 089.9. Again, that's almost 090. So I've plotted my azimuth line, and now I need to plot my intercept. My intercept is 12 nautical miles towards 090. So I need to find 12 nautical miles. So there is my intercept. Perpendicular line to my azimuth. Gives me an LOP that is pretty vertical. Again, doesn't matter where it is. We're just practicing doing our LOPs and creating our plotting sheets. So that is number 3 and number 6. Our next one, we're going to do 3 LOPs. So let's try that. Okay, so for number 7, we're going to be plotting 3 LOPs. We don't have a DR position or course and speed, but they did give us a mid-latitude and longitude to make it easier to plot our 3 assumed positions and LOPs. So our mid-latitude is 28 degrees north, so that makes this 27 and this 29. Our mid-longitude is 162 degrees east. So now we need to put in the rest of our longitude lines. So if our mid-lat is 28, we're going to find just shy of 30. Mid-lat on our longitude scale. So that gives us So now we have our longitude lines and our latitude lines. We can start plotting our assumed positions to get our LOPs. Our first assumed position is on the 28-degree north line at a longitude of 162.33. So I need to find 33. Right about there. So this is going to be my assumed position for number 1. My azimuth for number 1 is 135. So I'm going to find 135. So this is my azimuth at 135, and my distance away from my assumed position, or my intercept, is 6 miles towards. So I'm going towards 135 at 6 nautical miles. So I'm going to find 6 miles. So that is my intercept. I'm going to draw a perpendicular line to my azimuth. So that is my LOP for number 1. Now I'm going to plot my assumed position for number 2 of number 7. So 28 degrees, 161.52. So I need to find 52 on my longitude scale. So again, I'm starting at the 50 and going to the 2. So 0, 2, 4, 6, 8, 10. So that would be 52. So here is my assumed position for number 2. My azimuth for number 2 is 340. That is wrong. My azimuth for number 2 is 075. I wrote that down incorrectly. So yes, my intercept 20 degrees 2, azimuth 075. And I'm going towards 075. So let's find that. 075. So this is my azimuth line, and I'm going 20 nautical miles towards. So I find 20, and I'm going towards 075. So that puts me right here. That is my intercept. Put in a perpendicular line to the azimuth line. And this is my LOP for number 2. So I have LOP for number 1 and an LOP for number 2. So we're hoping that LOP number 3 confirms that this is where we are. Okay, so let's plot LOP number 3. We have a latitude, assumed latitude of 28 degrees, and our assumed longitude is 161.20 east. That was a correction on the homework, so it's 161.20 degrees east. We're going to find 20 even for minutes. So we're at 161.20 degrees. So this is our assumed position for number 3. And now we are going to draw in our azimuth line. Our azimuth is 0, 1, 0. And in this case, we are going to be going away from 0, 1, 0. So this is towards 0, 1, 0. We're going to be going away from 0, 1, 0. So our azimuth line is this way. And we are going to be putting in our intercept of 10 nautical miles. So there's our 10 nautical miles. Get a perpendicular line. Draw in, and we have a cross. So this is LOP number 3. So this is our position. Now it asks us, what is our position? So now we need to figure out what our actual position is, and we can put it on the chart. We can put it as a solid position. We can log it in our logbook, wherever you want it. So I'll put my pencil there, figure out what my latitude is. I don't have a time. Oh no, I do have a time. This is 1800. Okay, so my 1800 position is latitude 27 degrees, 41 minutes north. Longitude, I need to find what my longitude is. So I'm at 162 degrees. So I'm at 20 plus almost 2. So I'm going to call it 01.8 minutes east. Yeah, that's what I'm going to call it. So that is my Latin long by plotting 3 celestial LOPs. So you can erase all the other stuff on there if you want, but all you need is the LOPs. All right, let's practice our assumed positions were all given to us in this. So now we're going to practice calculating our assumed position. So here we go.
Let's, yes.
You kind of, in your earlier part of the discussion today, you kind of glossed over how you entered 229. I was wondering if you could go back over that.
Yes, so our number 8 of the homework assignment is calculating our assumed position in how we go into Pub 229. So now we're going to go back to the pub and start calculating things. Now that we've practiced a little bit of plotting. So we'll do at least the first two. And then we'll do, the next page is Pub 229 practice. Okay. So, oops. Our number 8, we start off with going back to our Nautical Almanac. So we are starting with the Nautical Almanac on April 13th. And these are all going to be the sun. So keep that in mind. th at 1800. Let me see if I can. Okay, so we are 18, 15, 23. That's our time. So we go into our Nautical Almanac. A little bit better there. Okay. 1300, or the 13th at 1800 gives us a GHA of 8954.7. I'm gonna write that in. 89 degrees, 54.7 minutes. And then I need to go to the minutes and seconds. We have 15 minutes and 23 seconds for the sun. That gives us 3 degrees, 50.8 minutes. 3 degrees, 50.8, excuse me. So then on my calculator, I can figure out what my GHA is. And I got 45.5 and 093. All right, so now I need to get what my assumed longitude is. So my goal here is to have my LHA as a whole degree, so I don't have to do that triple interpolation. So I'm in, this is my DR longitude, is 121.33 west. So if I'm west, I'm going to be subtracting. So to get it to a whole number, I have to subtract 45.5 minutes to get my LHA to a whole degree. So now I need to decide what is my degree part of my longitude? What is closest to ending in 45.5? In this case, it would be 121 degrees, 45.5 is closest to our 33.3. So now I can get a LHA 121 gives me 332 degrees, whole degrees, because it's 0 minutes. So I have LHA of 332 degrees. My longitude is this guy, which was 121.45.5. And then I need to get my assumed lat. So here I'm looking at my DR lat and saying, what's the closest whole degree? So I'm at 3720. So my closest whole degree would be 37 degrees north.
I have a question. I thought we were supposed to subtract the longitude because it was west. Did I miss something?
Yep. So it was 45.
Okay.
Oh, so you can't subtract 121 from 90.
Oh.
So you did 93. Oops. Can you see my calculator here? So 93 plus 360 to make it a big number.
Got it.
And then subtract 121 and you get 332.
Okay. I missed a step. Okay, thanks.
Yep. Okay, did that make sense in creating our assumed position? Okay, so let's try the next one here.
Okay.
Oops. Whoa. All right.
I'm sorry, Bree.
Yes.
I've got the how you got the assumed latitude. The assumed longitude is what? Or is that just LHA?
The assumed longitude
Yeah.
was what we created. We created an assumed longitude to get our
Okay.
LHA.
Got it. Okay.
My screen split for some reason.
I just have to label it that way.
Are you guys seeing like a split screen? Okay, whoa. Okay, now you guys can see the document camera, right?
Yes.
Yeah. Okay.
Yes.
So, yes, Ted, we created that assumed longitude because we had a GHA. That's what we calculated. And then in order to get a whole degree, and I was minusing, it had to end in 45.5. And then whatever is closest to my DR. So I did 121.45.5.
Yeah, I just didn't catch the label on that. Got it.
Okay, so then we got May 20th, number 9. We have a GMT of 01, 45, 15. So 01 gives us 195, 51.8. Okay, and then we go to the minutes and seconds, and we are at 45:15. So I have a minutes and seconds of 11 degrees, 18.8 minutes. We add those up. Oops, there we go. 1.8 plus 18.8 gives us 10.6. So we have a GHA of 207, 10.6 minutes. And we are in the west. So again, I'm going to be subtracting. So I know that my assumed longitude is going to be ending in 10.6. And now I have to decide what is closest to 155. Is it 155, 10.6, 154, 10.6, 156, 10.6? It's 155 again. I'm sure I'm going to come up with an example where it's the opposite. Yep, okay. So my assumed position is going to be that 155, 10.6, because this gives me 0. And then to put in this number, I get 207 minus 155 gives me 52. So I have an LHA of 52 degrees. I have a longitude of 155 degrees, 10.6 minutes west. And then my latitude, my DR latitude was 2245. So I'm going to say my assumed latitude is going to be 23 degrees north. That's what I'm closest to. Now again, if you put 22 degrees north, that's fine. You're just going to have a bigger intercept. So whatever you use, your assumed, you know, these are the three things. Well, they're not the three things, but your LHA and your assumed latitude are the two whole numbers that you go into the Pub 229 with. So you're just computing an altitude for an assumed position. That's essentially what you're doing. Okay, any questions so far? Our next one's east. So we're gonna figure out how to do an easterly one. Okay, so we're doing the sun. We're on November 25th. We have a GMT of 03:34:52. November 25th, we have a GHA of 228 degrees, 14.9 minutes. And then we have to go to our minutes and seconds table to get 34. 34 minutes 52 gives us 8 degrees 43.0. We add those up, we get 0.975. And yes, the 236. 236, 57.9 is our GHA. Now, because our longitude is east, we are going to be adding it. So we are adding it this time. So what do I need to get this to a whole degree if I'm adding? I need 0.2.1 minutes. Everyone see where I got that 0.2.1? It's basically 60 minus this will give me, so now I have a whole degree in LHA because I'm adding. I had 57.9 and I needed to get to the whole degree. So I'm going to add 2.1 and I get to 60, which is a whole degree. So now I have to decide, is it 151, 152, 25? I'm going to say it's still the same. I'm going to go with 150. So now when you're adding this, you have to keep in mind this is equal to 60 and you have to carry that 1 on the degree side. Make sure you remember to carry that 1. So we have 236 plus 1 plus 150 gives us 387, which doesn't work. We have to subtract 360 from that, and we get 027. So our LHA is a solid degree as 027. Our assumed longitude we've created as 150 degrees, 02.1 minutes east. And now we're going to look at our latitude. We have 15 degrees 35 south. So 35, we're going to round up to 16 degrees south. Any questions on the east and how we got an assumed position using east? Okay. Okay, let's do number 11. August 15th of the sun. All right, so we're at August 15th. Our time was 14:20:09. August 15th is 28:54.5. 28 degrees, 54.5 minutes. Then we go to minutes and seconds. We find 20. .09 gives us 502.3. Okay, so we add that up and we get 856 and 033. All right, yep. So we have a GHA 33 degrees, 56.8. We are again in the west, so we're going to be subtracting. So I know my longitude is going to be subtracted. So to get to 0, I'm going to subtract 56.8 minutes. And now I need to decide what that is closest to. So I have 079, 15.8 is my DR. So if I'm ending in 556.8, there's 79 degrees west, 78 degrees west, 80 degrees west. Oops. So if my DR is somewhere along this one at 15.8, but I need to end in 56, that's essentially this one or this one. The closer one would be 78.56. So I'm going to call my assumed latitude 078 degrees. My 56 gets to 0. We do 33 plus 360 minus 78 gives us 315. Whole degree. So then my longitude, I know I'm sloppy here, gives us 078 degrees, 56.8 minutes west. Our assumed latitude, we're going to round to the nearest. We're at 24.2, so we'll round down to 28 degrees north. How do you guys feel on that? Make sense on creating that assumed position?
Yeah.
Yeah. We just want to get the LHA to a whole degree and latitude to a whole degree, so we don't have to triple interpolate. And now we're going to practice interpolation. Back to 229. Okay. So on, I'm going to try to see if I can go back and forth here. Oops. Okay, so for number 12, we're just going to do one at a time here. Number 12, we have an LHA of 283 and we have a latitude of 22 degrees north. So I'm going to be in that volume 2, where it's 15 to 30, site reduction table. And then I'm going to find the first half of the book goes from 15 to 22. So I'm going to be in the first half of the book, and I'm looking for an LHA of 283. So I'm going to flip through the beginning of these pages. There's 297. Looking for 283. Oops. 38, 37, 285, 4. All right, so here's our 283. So we have 283 on this side. Let me make this smaller, sorry. 283 for latitude, same as the declination, and then we have 283 for the latitude contrary to declination. Our problem, we have a declination of south and a latitude of north. So we are on the contrary side. We're going to be on the right side. So we have 283 whole degrees, so I know I'm somewhere on this page. And then I have 22, so I know I'm somewhere in this column. So I know I'm, get this. Somewhere in that column. Too many books on my table here. And then I have a declination of 1236. So I'm somewhere in between 12 and 13 on my declination. So that's where I need to interpolate. Interpolating using my declination between 12 and 13. So we're going to use our site reduction table and plug in our numbers and see how this interpolation works. Our first one, I'll put it here. Is our HC. So HC is at the top. So our HC for 12 is going to be 7 degrees, 14.8. I didn't put in this in, but we have LHA of 283, declination 12 degrees 36, latitude 22 degrees north. Okay, so did everyone see where we got this 7 degrees 14.8? Yep. Right track here, okay. Okay, then that D, we're gonna write it in, is gonna be minus, see that little minus sign there? Minus 24.9. So we're going to put in our little d. I'm just gonna write it minus 24.9. I'm gonna write it smaller. Okay. There we go. And then, while I still have my 299 open, I am going to write in my Z and ZN. So I had at 12, my Z was 106.1 And then my next Z, so the 13, was 107.0. And that's what I have for what I read from my 229 here. I'm going to go back to my altitude corrections, and this is where we're going to interpolate. So from 12 to 13 degrees, because my declination, we subtracted 24.9 minutes. Well, I'm at 12:36. So how I interpolate this is I multiply 30, or I divide 36 by 60. So I have that fraction. It's 60% of the whole degree there. So 36/60ths times what it would take to move the whole degree. So 36 over 60 gives us 0.6 times our 24.9 gives us a correction of minus 14.9. So now we apply this correction to my HC. So I get 6 degrees, 59.9 minutes as my HC. You guys follow along on that one?
Yeah.
Yeah?
Yes.
Okay. So now we're going to do the same kind of thing for our azimuth, but they didn't give us the D, so we have to calculate that ourselves. So at 12, it was 106.1, and then at 13, it was 107. So the difference between that was an increase of 0.9. So they didn't give us that, but we can see that. We increased 0.9 degrees. Now I'm in between the 12 and the 13, right? This was at 12 and this was at 13. And I'm at 12:36. So I'm going to multiply this by 36/60ths. So I'm doing 60%. And I get a correction of plus, because we're increasing, 0.5. Now I'm going to apply that correction to my base, to 12, because I'm 12:36. So I have 106.1 plus my correction to give me 106.6 degrees. Does that make sense so far? We did another interpolation there. Our next step is to convert Z to Zn. This is where we follow the rules that are on our 229. We are in the northern latitude. So we have a latitude of 22 degrees north. So we are going to follow these rules here. We had an LHA of 283. So 283 is going to be greater than 180. LHA is greater than 180. So our Zn is equal to Z. So we go back to this guy. Our Zn is equal to Z. We don't need to change it in any way. So our ZN is 106.6. How we doing?
Okay.
Okay.
Bree, do you really need 100 to do Z or ZN to the decimal degrees?
No. You could round it. It's all about, you know, you're seeing it on here. So you're trying to get 0.6 out of
Right.
something this big. So
Precision there is only 1 degree.
yeah. Yeah. If you're taking the Coast Guard exams, they round to the nearest tenth. Okay. Let's do number 13. Any questions so far? Okay, so on 13, we are at a latitude of 24 degrees. So I'm going to be in the second half of the book to get to my 24. And then I have an LHA of 326. So I'm going to find. Okay, so I have a latitude of 326, and I have, a LHA of 326 and a latitude of 24 on the same page. Now I need to decide if I'm on the right side or the left side. I have a declination of south and a latitude of south. So I'm going to be on the right side under latitude same as the declination. So I'm at 326 and then I'm at 24. I'm going to put my little marker here. Let's see if we can get this all on the same frame. Okay. So my declination is 22:15. So I'm going to be in between here. My 22 degrees, 15 minutes south. I'm in between these two. When I write this in, I'll start with my HC. So I have 58 degrees, 42.8. And then I have a D as plus 10. I'm going to put a plus 10 right there. And then my fraction of the declination is going to be 15/60. So I'm multiplying that by 15/60. So I have 15/60, 0.25 times 10 gives us a correction of plus 2.5. So if I have 42.8 plus 2.5, That gives me 45.3. So my HC is 58 degrees, 45.3. Okay, now for my Z and Zn. My Z here was 86.7. I'm going to put 86.7. Dang it. $86.7 degrees. My next Z is 84.8. 84.8. And then I need to figure out what my difference was. So I went from 86 to 84, so I'm going to be subtracting. And how much am I going to be subtracting? .9. So I'm subtracting 1.9 degrees, but I'm only subtracting 15/60ths of that because my declination was 22:15 minutes. So I'm doing 15/60ths times my 1.9. And that gives me a negative 0.5. So I subtract that from, because this was my 22 and this was my 23, I subtract that from my 22. So 86.7 minus 0.5 gives me 86.2 degrees. And that is my Z. Now I need to convert that Z to Zn. So I go back to my rules. This one was for the north latitude, but I am in the southern hemisphere. I'm at 24 south. So I'm going to be following these rules down here. My LHA is greater than 180. My LHA was 326, so my LHA is greater than 180. So my Zn is 180 minus Z. Write that in there. So I have 180 minus Z is equal to Zn. So I have 180 minus 86.2 gives me a Zn of 93.8 degrees, or 94 degrees. How's it making sense so far? All right. I'm going to let you loose, and you guys try number 14 for the next 5 minutes. Try it on your own. See how it goes. These are our answers. Anybody get something different?
I used the correct table, no.
So which table did you make a mistake on?
I think, let's see.
Did you do contrary instead of same declination?
Yeah. Well, the other way around. I did same instead of contrary.
Okay, so you were on the wrong page.
Right, yep.
So another way that you'll quickly figure out if you're on the wrong page or not is if that HC is ballpark what your HO is. You've already calculated your HO. So that HC should be within a degree or two.
That makes sense, yeah.
Of what you're looking for. If it's completely not, then maybe you're on the wrong LHA. You know, time to go back and look at some more, just so you don't have to redo the whole thing from the start.
Right, okay. So I would have been off by 20 degrees, so that would have been the big indicator there.
Yes, yes.
Got it, okay. Makes sense.
Okay, well, the next part of the homework is a full site reduction.
Okay, so for our last problem, number 15, we're going to do the full site reduction. So they gave us, we're approaching Hawaii, we have a DR position, and then we have 4 stars that we saw for our evening stars. And they give us our sextant altitude and our chronometer time. So we have to correct our chronometer time to, with chronometer error, convert it to GMT, and then for going from HS to HO, we have our index error and our height of I. So we have all the information. I have printed out the star site reduction form. So we have site reduction form for the star, and I am just going to plug in the information that they gave me. Okay, so I have just put over the information that they gave me in the problem onto my site reduction form, so I can start filling in and see where we're at. So when we do a site reduction form, and I already have 4 sites or 4 LOPs that I'm going to be doing, you can do one full one, and then one second one, one third one, one fourth one, etc. Or you can do them all and then, or kind of all step by step, and then put it on the sheet. It doesn't matter which way. I find that's a little bit of a time saver if you do it all step by step. That way you're going to the almanac once and getting all 4 values, and then going to Pub 229 once and getting our full values instead of going back and forth. It does make it a little bit more confusing because you are managing 4 different numbers, kind of thinking about things. So up to you if you want to do one at a time or each one. So I'm going to do all of them at the same time, but again, up to you. Okay, so we have February 14th, we have a DR. Our zone time was 1820 with a zone description of +11. So I'm going to see what our GMT, approximate GMT time. So if I do 18 plus 11, I get 29. 29 minus 24 gives me 0.5. So my GMT time is 05:20 on the 15th, on the next day, because we added that 11. So my chronometer time will be the 5 instead of 1700, but it will be on the 15th. So I got to make sure when I'm looking at my almanac, I'm looking at the 15th, not the 14th. So I'll write that in there. We have a chronometer time for each star, and then our chronometer error was the same. So it was 1 minute and 20 seconds slow. So if it's slow, we have to add it. So we will add it here. So now I have my GMT time, and those are all on the 15th for each of my stars. I just added in my time, and now I can go to my nautical almanac. Okay, so I copied the page so I can show you side by side and draw on it, but it's just a copy of February 15th page from the almanac. So our first step here, now that we have worked our way down to having our GMT and our date, is the GHA of Aries on the top of the hour. Then we'll add our minutes and seconds, our SHA of the star to get our GHA of the star. Create our assumed longitude to get LHA, and then we have LHA, declination, and lat that we can go into Pub 229. So our first step here was GHA of Aries. So we are on February 15th at 5. So that would be the top of the hour. So our top of the hour of 5 o'clock is 219 degrees, 40.6. And all of these are at 5 with a little bit of change. So it is the same. I will put across. So now I have my GHA. Before I go to minutes and seconds, I'm going to write in my SHA of the star. So on this page, we have our 3 stars, and they're in alphabetical order here. So our 4 stars, excuse me. We have Daifa, and we have Capella, Hamel, and Mir. Okay. So for our stars, our SHA and declination are the same for all 3 days. So it doesn't matter which hour we're at on this. So we're just going to write in, we have the SHA and the declination for each star. So I'll start here with Capella, my SHA, and my declination was north. My declination goes here. So I'm just plugging in my SHA and declination using the information here. Okay, so now I've plugged in everything I need from this page. So we're done with that one, and we'll go to our minutes and seconds to add in what we need here. So we start at minute 19:05, and we kind of work our way through the minutes and seconds. So minute 19:05, and we are looking at Aries. So we need to look at this column right here. So we have 4 degrees, 47 minutes. For our 19:05, 19 minutes, 05 seconds. That was our time here. Now we got one about a minute later. At 20:09, so 20:09. Then we're at 23:30. again, you always want to go from Aries. So now we have our minutes and seconds. And now we are going to add up our GHA, our minutes and seconds, and our SHA to get the GHA of the star for all 4 of these. Okay, so we got GHA of 213.19 minutes. So if you saw on the calculator, all of our minutes added up to 130 something, so we had to subtract 2 degrees to get something that was under 60. And then we had to carry that 2 degrees over, and we got a very high number on that, and we just subtract 360 to get a number we can work with. So we have 213 as our GHA. Now I'm just going to add up our GHA of the star for the rest. Okay, so now we have our GHA of the stars, and we need to create a assumed longitude that will make our LHA a whole degree, so it has 0 minutes. My longitude, I'm approaching Hawaii, so I'm in the Western Hemisphere, so I know I'm going to be subtracting. So I'm going to be subtracting the minutes section to get to a whole degree. So I'm just going to put in my minutes here. I'm going to be subtracting whatever I have left over to get to a whole LHA. And now with these minutes, I need to figure out what my closest DR longitude would be. So right now I have a DR longitude of about 157.48 degrees west. So if I have 19.1, again, I will make a okay, so I think I'm somewhere along this longitude line. Now, if I need to end in 19, I can either be 157.19 or 158.19. So I've figured 157.19 is going to be closest to 158. So I'm going to go with 157 degrees. Of course, if you go with 158, that's fine. You're just going to have a different intercept, different HC than I do. So not a big deal. You'll still get an LOP. Capella ends in 1-1, so I'm either going to be very close to this one or very close to this one, and this is my DR. So in this case, I'm going to go with 158 degrees, 11.2. I think that's closest. This one ends in 29.8. So I'm either going to be here or here. Closest to 48, I'm going to go with 157. This one's 17.9. 17.9, very close. My quick test for this is if I add 17.9, or if I add 30 minutes to 17.9, I get, what do I get? 47.9. So the 17.9 on this side would be closer. So I'm going to go 158 degrees. Again, if you do 157, does not change the overall outcome. You'll still get an LOP. It will be different than mine, but it will still cross through where you think you are. Okay. So now that I have created my assumed longitude, I can calculate my LHA. And I'm going to be subtracting. So I have 0.56 degrees for my longitude, for my LHA, using my assumed longitude. Let's do the rest. Okay, 145 minus 158, we can't do that. So we have to add 360. So now I have a whole LHA. My latitude, I have our DR latitude of 2150. So my closest latitude would be 22 degrees north. So I'll put that in. So now I have all three things that need to go to my pub 229. So that's great. Before I switch over pubs, I have to correct my altitude, my sextant altitude, to my observed altitude, and we use our nautical almanac to look up the corrections for that. So let's bring in nautical almanac. We have our sextant, our raw sextant altitude already in. We got our index error right before we shot, so I put that in. And then for dip, we're always going to subtract dip, and we use our formula here, our table. Height of eye was 27 feet, and then we have a correction. So 27 feet, that's in between the 26 and the 27. So our correction is going to be minus 5 minutes. So minus 5. Okay, so now I can calculate what my apparent altitude is, my HA. I'm getting a negative number, so I need to borrow from this side. So this turns into 23, and I have 62.7 minus 12 minus 5. Now 23 minus the 1 gives me 22. Okay, now I'm just going to do the rest for the remaining. Okay, so I have for my A2 correction, they are all above, in between the 10 and 90 degrees. So I won't have to use the A3. I'm going to be on this table. I have for stars and planets, my apparent altitude, and then my correction. So my apparent altitude for here was 2245. So I have a correction of minus 2.3. Here I have 63 in between here. So I have a correction of minus 0.5. There it is. In between 60 and 65 was our 63. Apparent altitude here was 57 degrees. So that's going to be in between our 56 and our 60. So we have minus 0.6. And our 59 is the same, minus 0.6. So now I have my A2 corrections. I don't have an additional correction for Venus or Mars. So don't have anything here. And now I can see what my HO is. Okay, now I have my HO, and I can move that down here. I'm going to calculate my HC first and then move it down. So to calculate HC, our next step is going to Pub 229. So let's bring that out. Okay, so for my first star, DIFA, I have an LHA of 056, a latitude of 22, and then I have a declination of 17. So I'm going to find the page with a latitude or LHA of 056. So I have 056 here and a 056 on this side. So now I need to decide, is my latitude the same as my declination or contrary? So back up here, I have a declination of south and a latitude of north. So I'm going to be contrary. So I have LHA of 56, a latitude of 22, and then I have a declination of 1752. So I'm going to find 17. So I'm going to be somewhere in between these numbers. And we're not going to triple interpolate because we don't have to. But I'm going to write in the information from this little spot that I transpose into my my site reduction form. So for HC at 17, I have 22 degrees 43.5. I'm going to write that in there. So right off the bat, I know I'm ballpark in the right area because I'm pretty close to that other HO that I did. So I'm very close to it actually, but I still have to interpolate for declination. So interpolating for declination, I'm going to write in my little d. So my little d here is minus 33.4. So I'm going to be subtracting 33.4. But I need to interpolate with that. So interpolating with my declination, because I'm going from 17 to 18. and my declination was 1752.9, so almost 18, but not quite. So we are going to multiply this by a 52.9 divided by 60, and that's how I get my correction. So gives me a correction of 29.4. So I'm going to subtract 29.4 as my correction. Go back to my gives me an HC of 22 degrees 14.1. So now I have my HC. I could bring in my HO. I'm just going to move it down to the bottom so they're right next to each other. Not to the bottom all the way. So this was my HO. I just moved it right down there. So now I have the difference between my HC and my HO. And we have HO, MO, TO is a common reminder that if our HO is more than our HC, which it is, it's 43, and our HO is only 14, our intercept is going to be towards. So I'm going to add in a 2 right there. Now I need to see what the difference between these are. To get my intercept. So I have 29.3 minutes or nautical miles towards my azimuth. So now I need to find my azimuth. And that's right here on the same page. My Z, I'm going to use these two numbers here. I'm going to plug them in and show you how to interpolate. So my first one, okay, so for the 17 degrees declination, I had 120.7, and for 18 degrees declination, I had 121.6. So they don't give me the little d, so I have to come up with that myself and get what difference I am using. So I have I am actually adding 0.9. And I'm going to do the same type of interpolation where I'm going to multiply it by that fraction to get me to the next declination, because I'm only at 52.9 60ths. So I do 59. Gives me a correction of, I'm going to round that to 0.8. So I apply that correction to my 17, because I'm going 17, 56, 52.9. So 120.7 plus 0.8 gives me a Z of 121.5 degrees. So now I need to convert that to my ZN. I'm in the northern hemisphere, northern latitudes, so I'm going to follow these rules right here, where if my LHA is greater than 180 or less than 180. If you look at my LHA, it was less than 180. So I'm going to follow the rule down here that says ZN equals 360 minus Z. So when I go back to here, I'm going to do 360 minus 121.5. And I get a azimuth or ZN of 238.5. Again, you could just round that to 239 if you want. And then for advancing or retarding, they're all pretty much around 1820, so I'm not going to do that in this. For sun lines we do, but depends on when you get your stars for this one. So so my first one's done. Now I'm going to do Pub 229 for the rest of them. So yes, once I get to Pub 229, I kind of work all the way down, so I'm not going back and forth with my pages. Okay, so for Capella, we are at 347 LHA. So I need to find 347. Okay, so I have 347, but I need to see if I'm contrary or same. In this case, I have a declination of north and a latitude of north. So I'm going to be the same. I'm going to be on this side. So I still have my LHA of 347, my latitude of 22 degrees, and then my declination is going to be 46, just a little tiny bit over 46. So I'm going to go down and find 46. So these are my numbers that I'm going to be looking at, and I'll plug in here. Okay. So my HC is going to be 62 degrees. Again, I wrote that down and I could see it's ballpark HO, so I'm good to go there. My little d was minus, and I'm going to be multiplying that from this declination, which is 01.1. So I have 01.1 divided by 60, which is going to give me a very small number. About 1. So I'm going to be minusing 1.0. I rounded that from that number right there. So I have an HC of 63 degrees, 45.3 minutes. That is my HC. Now I'm going to move my HO right down to the HO line. And I can get the difference here for my intercept. So I'm going to look first. Is it ho, mo, to? No, it is not. My HO is not more than, so it is not towards. It would be away. Now I can see how much away. Very, very close. So 3.4 miles away. Now for the Z, on this side, we have a Z of 20.7, and our next is 19.7. So my difference there is going to be subtracting 1 degree. Be multiplying that from 1.1 over 60. Again, very, very small. Gives me a very, very small number. So I'm going to say there's nil, no correction. So my Z is going to be 20.7. Now I need to convert that to ZN. Again, I'm in the northern hemisphere. So is my LHA greater or less than 180? In this case, it was greater than, so my Z equals my ZN. So 0 to 0.7 is my azimuth line. Now we're going to do Hamal. LHA here was 036, latitude 22. So let's find 36. Okay, I have an LHA of 36 here, but I need to decide if I am contrary or the same. So I have 36, declination north, and latitude north. So I'm going to be on this side with my 36 degrees LHA, 22 degrees latitude, and my declination is 2330, so right in between 23 and 24. Okay. So my HC for my 23 is going to be 5648.5, so I'll write that in there. And I can see right now it's ballpark the same, so we are fine with that. Then I have my little d, which is going to be a plus. There's a plus right there. A plus 4.9. Plus 4.9. My interpolation is on the declination. So I'm using the 33.3 for my interpolation. I have a correction of 2.7. So I have a calculated HC of 56 degrees, 51.2. I'm going to move down my HO. And see what my intercept is. So which one is larger, HC or HO? My HO is larger, so HOMO-TO, we're going to be going towards, and larger by how much? So we need to do 65.4 minus 1.2 gives us 14.2 as our intercept, 14.2 nautical miles. So now we're going to go with our Z, our azimuth. So here at 23 for our declination, we have 081.2. And then our next Z was 079.4. So we need to figure out what the difference is. They don't give it to us. We are subtracting 1.8. Again, our interpolation number comes from our declination. So our 33.3 60ths times our difference gives us a correction of about 1, minus 1. So our Z would, minusing from our original Z there, would be 080.2. Now we need to convert using our rule. We're in the northern latitudes. Was our LHA greater or less than 180? Our LHA was 36, so it was less than 180. We're going to do 360 minus Z. So 360 minus 80.2 gives us a ZN of about 280, 279.8. Okay, so that was Hamal. And now we are going to do our last one. We are looking for a LHA of 16, latitude 22. So 16. Okay, we're at a LHA of 16, and we need to decide if we are contrary or the same. So in this case, our declination is north and our latitude is north. So we are going to be on the same in this column again. Our declination was 49.56. So all the way down at 49, almost 50. Be pretty close to that number. So back to our interpolation or site reduction table here. We're going to put in our base HC. HC is here, is 6009.8. We are ballpark the same, so we are good to go there. And then we have a little d of minus 51.7. So there's our little d correction. We need to multiply it by our interpolation of declination. So we have 56/60ths. I'll be subtracting 48.3. So I'm going to do 69.8 minus, gives me 59 degrees, 21.5 as my HC. I'm going to move down my HO. And I'm going to calculate my intercept. So which one is larger? My HC is larger, so I'm going to be away on my azimuth. And then I need to calculate what my miles are, and I have 20.9 nautical miles. So that's my intercept. Now I need to get my Z and ZN. So my Z at 49 was 21.3. And my Z at 50, 49 and 50 was 20.3. So my difference is subtracting 1 times my 56/60th. That's from my declination, about 0.9. So I'm going to be subtracting 0.9, 21.3 minus 0.9 gives me a Z of 0 to 0.4. Now we need to convert to ZN. Back up to the rule, is my LHA greater or less than 180? In this case, we were less than 180. So we are going to be 360 minus my Z. Gives me 339.6. So now I have my complete site reduction form filled out. So I'm going to highlight what I need to plot on the plotting sheet. So I need my assumed position. So that's going to be my assumed longitude and my assumed latitude. And then I also need my intercept and my azimuth. So my intercept is here, and my azimuth is here. So I don't need any of the other numbers. Those are the only 4 things I need to plot. So I will get started with plotting. Okay, so I know my assumed latitude, and so I'm going to make that my mid-latitude was 22 degrees north. So I'll make this 23 and this 21. Okay, so now that I have my latitude lines drawn in, I can draw in my longitude. So I'm going to call my longitude 158 degrees west. If you use 157, that's fine. For my latitude, I have 22 degrees north. So I use my mid-latitude scale over here. Call this about 22. And now I can draw in Okay, I have my longitude lines in, and I'll just fill them out. 157. Okay, and now I can start plotting I'm going to plot each one individually. So I'll do assumed position and then plot the LOP for each one individually. So here my assumed position is on 22 north, and my longitude is going to be 157, 19.1. I'm going to find 19.1 using my longitude scale at the bottom here. Call that about 19.1. So I'm at 157, 19.1. So this is going to be my AP for DIFA. My next thing to plot is going to be my azimuth, and I'm going towards my azimuth. So I'm just going to draw my azimuth line of 238.5, so about 239. Okay, there's my 239. I'll bring it over to my assumed position, and I'll draw in a line. Now my intercept was 29.3 towards. I'm going to find 29.3 right about there. Start at my assumed position and call this my intercept. So in order to draw my LOP, it's a perpendicular line to my azimuth. So I will find my pencil here, find my perpendicular line, and draw in my LOP for at what was this at? Was 1819 DIFA. So I have one LOP done. I need to plot my next one. This same latitude for my assumed position. This longitude was 158, 11.2. So I need to plot that. So 158, 11.2. I have my assumed position for Capella. My azimuth is 0 to 0.7 away. So I'm going to be going away from about 121. So 0 to 0.7. Right about there. Bring it to my assumed position, and instead of going towards 0 to 0, I'm going away from 0 to 0. So here's my line, and my intercept was 3.4, very small. So let's find 3.4. 3.4. From my assumed position. So here, this can be my little intercept. Draw in a perpendicular line. And now we have an LOP at, what was it, 1820, and this was Capella. So we have a cross, that's good. Now we're going to put our next two to see if we get a tighter or a more accurate position. So our next assumed position for Hamal is 22 north, and then 157, so we're back on the 157 line at 29.8. There's my 29.8. Here's my assumed position for Hamal. And my azimuth was towards 279.8. So let's find 279, about 280. And we are starting at our assumed position, and we are going towards 27. So we are going to be going this way. There's my dashed line. My intercept is going to be 14.2. 15, a little bit over 14. There's my intercept. And I'm making a perpendicular line. This is looking like it will cross very close. That is great. This is my, what time do we have? My 1822, and this is Hamal. So we have an 1822 line, and now our last one is Mirfak, and we are going from 158 or 22 degrees, 158, 17.9, almost 18. So here's our assumed position for Mirfak. And our ZN is 339 away by 20 miles, 20.9 miles. So 339.6. There's 339. My pencil on my assumed position. And instead of going towards 339, we're going away from 339. Drawing my line. And my intercept is going to be 20.9, about 21, about 20.9. So this is my intercept, and I'm doing a perpendicular line. And we have all of them crossing, which is great. So this was 1822, and this was Mirfak. So now I don't even have to guess. I have all four of my lines crossing at one pinpoint. So now what is my latitude and longitude? That's my latitude line. So I can read that my latitude is, so I'm going to say my 1820 This was 19, 20, 22, 22, so maybe you call it 1821. I'm rounding it to 1820. My latitude was 21 degrees, 58, no, 48, excuse me, almost 50. 48, doing it again, 48 minutes north. My longitude here's my longitude. Bring it down to my longitude scale. I'm at 40, about 48, maybe 48 and a little bit of change, but we're going to call it 48. So we are at 157 degrees, 48 minutes west. So that was my star fix. My DR was 2150 and 5748. So very close, somewhere around there. So that's a good sign. I'm very close to my DR. And I've got a tight pinwheel is what they call it. So that's great. I will scan these and put them on the Google Classroom. And let me know if you have any questions. I know it was a lot of work to get one little answer, but we'll be doing it soon. All right. Thank you, guys. Have a good one.